Thanks, Andy, for that great introduction. Just get my timer set so I don't bore you guys for 5 hours. There we go. I will do it. Don't laugh. I really will. So, okay, let's start with some audience participation. Pop quiz. What state of the Pi? What is the state Pi of Texas? Shout it out. Any guesses? Pecan. You guys are right. That is the official state Pi of Texas. But actually, pecan pie is tasty, but it's not what my talk is about. I'll talk about taste later on, but not initially. Initially, what I want to talk about is something that Andy touched upon, which is sort of looking back at the history of PyData, which is not a very long history, right? We've only been doing this for like 3 years. But a lot has happened in the last 3 years. And as Andy mentioned, we started off, the first PyData workshop that we did. It was a workshop, not a full conference. It was only about, a handful of people really that showed up. But it was just something we did at Google. Google headquarters in Mountain View, and it was really, really nice. Julie Steele from O'Reilly helped us put it together, and we got a lot of developers from the SciPy community to meet with people who were at Strata, and it was just a really nice sort of event. We did also confront confront Guido about a couple of things, but we all had a great time. And in the 3 years since then, so that was the first event, and 3 years since then we've had quite a few. I'm probably missing some, and there's certainly meetup groups that have sprung up across the world. Using the name PyData, and most of them get in touch with us and NumFocus and get become connected to the larger organization. And we have more coming up. More and more companies are starting to realize that PyData as an organization, NumFocus as an organization exists, and so it's been really great. And it's great because many organizations are using Python. Right? There's a lot of people who are using Python all the time. And if you look at this list, it's not like marginal, small little 2 guys in a little garage startup. These are actually really large companies, and many of them they're not just dabbling in it, right? They're analysts and data scientists actively rely on Python, and in many different ways. I mean, you see up here, ILM is Industrial Light and Magic, and many of the people in Hollywood rely on Python to run the rendering pipelines for the movies. People don't really talk a lot about that, but it's just the reality on the ground. Likewise, when you look at some of the stuff, data science, especially in the Bay Area companies, a huge portion of that just runs Python. And there's not, the thing is that they don't really tout it. Python is not this sexy new bandwagon you get on to get your CIO all excited. It's just a thing you go and you use. And so that's actually a very interesting thing. And this is what led to Travis and I actually starting, really starting the PyData conference and trying to create the nonprofit and get more people involved around the use of Python for data science. Because we saw that many of these different people, talk to data scientists from almost every one of those organizations, and scientists, and just programmers and operations people over the last 3 years. And talking to all of these people, what you see is that there are some unified challenges, especially the data scientists, across from a bank to the intelligence community to people working on ad analytics to the Uber and the Spotify people. Like all these folks are using Python in different ways. But there's some core common challenges that data scientists have. One of them is that there is legitimately a much larger volume of data that's coming down the pike. And everyone is seeing that. It's not just the marketing term. As much as many people don't like the term big data, the reason it's so sticky is because the fact that it does identify a real problem people have. Now, the problem is that big data as a term is not sufficiently concrete for people to know what kinds of solutions, what kinds of approaches they should take. Because it's just a term that means my current stuff doesn't work anymore, right? My current stuff is broke. It's bigger than Excel. And so people then rush into this market, and what we see is there's just a giant proliferation. There's a mass proliferation of tools, technologies, databases, services, even trainings, and all these other things that are happening. But really, the products and the offerings in the space, excuse me, getting over this cough. So the products and the offerings in the space, they oftentimes create more integration headaches. They very, very seldom, especially for people with lots of data and real problems, they very seldom can find one off-the-shelf product that just fits their needs. And so whatever you buy, whatever you bring in, inevitably there's some integration thing that has to be done. And that integration challenge, everyone knows it's there, and that is one of the things that actually is a friction to adoption, right? So people, for instance, with new hardware and new architectures that are coming down the pike with SSDs and NVMe and then just GPUs and all these different kinds of things, there's a lot of cool capability there, but people don't even have time to do the problems they currently have to go and explore and integrate these new kinds of technologies into their current backend and into their workflow is almost an impossible problem. And of course, in recognizing these first three things, then there's many companies and startups coming along the way now too that also promise just one big red solve button, or in some spaces they would call it the big red predict button. And that prediction button, that solve button, if it actually works for you, then the problem is that your vendor is your competitor, right? Your vendor is not actually, because then you're not adding any value to the process. And so that's the really big challenge in this space. And I think many of the people, again, that I talked to at the previous companies on the previous page here, many of them are sort of reflect these ideas or have even articulated these ideas to me, that these are the common challenges that people see across all these different verticals. And there's not really a single silver bullet for all of these things. And what I would say is that, when talking to all these different data scientists, I sort of think of them as bush pilots. I don't know if people are familiar with this term. How many people know what this term means? Bush pilots? Wow, awesome. Because we have great weather for flying here in Texas, right? So a bush pilot is essentially just a term for pilots that fly into places that other more sane pilots don't fly into. So, commercial aviation, I think like the world of data warehouses and business intelligence and all of your master data management and all of your traditional data-oriented business processing stuff, that's a very, very mature field. It has tens of billions of dollars of economic activity happening in that technology market. And that's like the equivalent of, your like DFW, paved runways, right? And a tower to control people landing. Bush pilots, however, they get in a plane and they fly wherever they need to, and they land and they deliver stuff that the people at their destination need. And so scientists have been in this camp for a long time. We see data scientists now doing the same thing. There's an entire uncharted continent of valuable data and analytical routines and everything. No one has paved a runway there. No commercial 747 is going to attempt a landing there. There's hurricane force winds. No one flies in there except for the scientists and data scientists who just absolutely have to get in there. And so they actually have better piloting techniques than the commercial airliners, where you hit the autopilot once you clear the runway. And so what we're seeing is the reason why so many interesting tools in open source, Python, R, Spark, Hadoop, whatever, you name it, a lot of the open source tools are being generated by the people doing the work, because bush pilots are the ones that actually know how to fly, right? Once you are in a situation where you're used to just buying stuff from a vendor, you kind of forget how to do the engineering of the stuff underneath. And so the thing I want people to keep in mind here is we're looking at the later slides and the rest of my talk as I talk about the tools and technologies. These are all coming from people who have done the work. They're legit in the trenches doing the work, and they produce these kinds of tools. And so that really leads to this kind of next section I want to talk about, which is why Python, why now? And just as one note, even though I talk a lot about Python here, I think other languages and tools like R in this kind of open source, open data analytics space also fall into the same kind of category. And so I'm just going to talk about Python because that's kind of what I know best. But if we look at PyData and we look at Python, I talked about PyData being about 3 years old. Actually, PyData is about 20 years old. And all the tools, well, almost all the tools, and many of the underlying technologies in the PyData ecosystem are from the SciPy ecosystem and from the scientific Python, stuff that's been maturing for 15 years at least. And those things are even, built on even earlier things. So the matrix object and numeric, those are very old at this point. And the ideas from there are still embedded in the code that many people are writing today. And if not embedded in your code directly, they're embedded in the tools that your code is using. And this age, kind of this legacy is not in any way meant to be sort of denigrating, right? I'm not saying this stuff is old and broke and you should go use something else. What I'm saying is that the SciPy community and the scientific Python community, they have been developing these techniques for bush piloting, right? They're developing these kinds of airplanes and these kinds of piloting techniques for a very long time. It's grounded in the history of like the MATLAB and the Fortran and the APL world, which is really very, very old at this point. So when I talk to people, oh, you guys can't see that at all. That's too bad. Actually, it puts Totoro in the shadow, which is really cool. But so there's actually rain. You can't really see this. I mean, you probably infer from the fact that the little girl's holding an umbrella. It's not a big data problem to see if there's rain there. But actually, when I talk to people, when we go to like the Strata and the big data events, things like that, a lot of the marketing literature that you see from folks talk about, they use a water metaphor, right? It's the torrential volumes of data pouring down and all this other stuff. Data lakes, right? Data pools, things like that. And what I sort of, thought was a great expression is the idea that Python is a nice umbrella technology. Maybe it's a rain jacket that data scientists like using. It keeps them dry, lets them do their work, even as all this stuff is raining down. And so apropos of the scientific Python stuff, really the reason that the rain jackets and the umbrellas are so good is because the scientific people, the scientific Python, scientific computation people, have been drowning in data for decades now, right? So those umbrella technologies come from like this water world where these people are building boats, and yes, they need a rain jacket because it rains, because it's wet on the ocean. But really, the idea here is that many of the tools we're using in data science, the umbrellas and the things to keep us dry, to let us be agile over data, those come from a world that's just been steeped in data and high demands for computing for a very long time. And one of the things that, we talk about big data, and we talk about the torrents of data and all this stuff, and people talk about how we're in the era of big data now. And I actually really disagree with that. I think we're just starting on that. I think really the challenge people have is that we're in the era of broken PCs. So the data is big, but that's not actually the problem. The problem is that your current stuff is broke. And when the really big data hits, it's going to be, you're just completely overwhelmed, right? Everyone who's still using an Excel-based workflow is just going to be blown out of the water. And so let's talk about broken PCs. Let's talk about the PC and how we got here. So if we look at a brief history of computing, very, you guys laugh, but it's actually not that funny. Maybe I'll make you cry by 3 slides in. But the thing here is that if you look at the early history of computing, it's not that long ago that we were starting off with digital general-purpose computers as being a new thing. And shortly after, we invented Fortran, right? And then we invented the semiconductor integrated circuit. So Fortran actually predates the semiconductor. I don't know how many people here knew that. But then eventually we got to, by 1969, we got to ARPANET, which DARPA created in the wake of actually the SAGE project. And ARPANET is the precursor to the internet. Many of the ideas, most of the ideas behind the internet arose in ARPANET. And what the lower right picture shows is a guy named Doug Engelbart doing this amazing demo in 1968. It's called the mother of all demos. How many people here, show of hands, know what that is? Heard of it? Okay, a smattering of people. So it's called the mother of all demos because in 1968, a year before the creation of ARPANET, he demoed a mouse, he had Windows, he had video conferencing, he had collaborative editing with hyperlinks in a document, he had a laser light pen. He did this only 10 years after the invention of the semiconductor integrated circuit. And so he was basically doing Google Hangouts and Google Docs with a light pen, all right, 1968. And just this week, I was trying to do Google Hangouts with someone on Chrome, and it wouldn't pick up my audio. Like, it was all weird. But 1968, this guy was doing this. So, so that all happened a very long time ago. We kind of got to this point, like at least a demonstration of feasibility as a prototype. And then the 1970s is where things really accelerated, and we actually laid the groundwork for a lot of what we have today. The C programming language, which we all of us use one way or another. Ethernet and Unix, which many of us use directly, even if you're using a Mac, you're still using a Unix, right? It's not Linux, but it's still a Unix. And then DOS, which is still at the heart of the Windows platform, was based on CP/M, which was created in 1974. And by 1978, we'd created VisiCalc, which is the precursor to Excel. I mean, we as a species, not I, had anything to do with it. But as a species, we figured out that Excel was kind of a cool thing. And that was 1978. How many people here were born after 1978 and after? How many people, show of hands, yeah, see? So by the time that we showed up on Earth, all this stuff already existed. So what have we had since then? What has happened since then, really? Right? Since then, it's what I call the long shadow of the 1970s, because basically the popularity of the personal computer and the dawn of the personal computing age meant that we didn't have to do as much hard work on the back-end computing concepts. We could just build applications, stick them on a machine, and put that in some place where it was pen and paper. And even the crummiest application on a 4 megahertz chip is better than pen and paper. And so we didn't have to work any harder than that for a long time. And so we are still living in the long shadow of the 1970s. If you look, the Hadoop stack, right, and a lot of the Apache stack for big data, based on Java, something that was invented 20 years ago, right? And then we can't really throw any stones at that because Python was also invented a long time ago. So all of these things we're using today are actually incredibly old. And when we consider the fact that we replace our smartphones every 2 years, right? So this is actually a this is something that, if you sit down and think about it, I think many people would intellectually be able to arrive at this. But to actually understand viscerally what it means, that we're using 25-year-old technology and we still believe it's cutting edge, what does that really mean, right? And the reason of going through this progression here is just to show that, it's not to make people feel bad, but it's to show that there was a rapid progression of stuff happened through the 60s, and then kind of through the 70s, and then we sort of just slowly evolved and made evolutionary incremental changes on things. So I think part of the reason that that this has happened again is because software is really effective. Even bad software is better than like no software. So that's kind of Mark Andreessen's software is eating the world thing. But it does kind of lead us to this question of like all the new things that people are excited about, people are concerned about, people are talking about, reading about, going to conferences and learning about. How many of these things are really innovation? How many of them are churn? And by churn, I mean they're hacks around older hacks. Or in some cases, hacks around older hacks around older hacks. But not like drilling to the bedrock and understanding what is the real problem here. What is the hardware capable of? What is the software capable of? What is my question I'm trying to ask? What is my task, my computing task I'm trying to achieve? And how do I build something around that? So these are all things. I think many people looking, probably not everyone, but many people around the room will be able to look at this list and understand what I mean by each of these little bullet points and has at least dabbled with some of these technologies. And you look at this and you're like, are these things fundamental? How many of these things are fundamental? Maybe they're fundamental for certain things, but how many of them do I need to be concerned with if I just want to get to some business insight at the end of the day? So, another thing that we can look at is when we look at all of the virtualization, in a different way, looking at the software stack, just the software stack side of things. We have so many different kinds of technologies coming around as browser runtimes become very fast and become in the forefront of people's minds. There are a lot of things hitting JavaScript, a lot of things are on virtualization, all of these different things. It's like it's a technology soup, but it's also there's something deeper there. There's a kind of deeper sort of I think disquiet. Sort of. I've always loved that picture when people talk about containers and Dockers and vagrants and all these other things. Like, at some point there is something hitting the water. There's bare metal somewhere, but you don't know exactly where in that stack you are sometimes. But really, what I would say that is right now, when we look at the Python land and some of the tools and some of the arguments and discussions happening around Python technology, whether it's packaging, whether it's the JIT, whether it's async I/O and parallelization, whether it's the GIL, all of these different conversations that we have in Python land, all of them are actually, they reflect the evolution of the underlying technology space itself. And my overall broad brush kind of view of that is that we're moving from being, the early days of computing were around hardware. People built better hardware. They would make hardware startups to build chips that did something. And then at some point, the hardware became good enough to where people could build software. And Bill Gates invented the concept of charging for software and made a lot of money doing it. And so we had years and years, decades of people building just software. And at some point, when the software is good enough and there's too much churn there for people to be concerned about, then we can layer on top of that cloud services and kind of, by services here, I don't mean like professional services and consulting, I mean services, endpoints, things like that. And so I think that's the evolution we're kind of getting to. And when you look at the tooling around orchestration, DevOps, those sorts of things, they're really trying to get themselves away from that churn. They want to insulate, these are developers who want to insulate themselves away from the churn in the hardware and the software space and really just get to a point where they can offer a REST endpoint or a front-end browser or mobile visible application. And so they're really not about software development at that point. They're really about deploying services. So there's a lot of blurring. There's a lot of blurring and confusion, I think, in the software space because it's bifurcating. There's some people who still really want to do software, and there's other people who really want to build services and see software as a means to services. Imagine if software developers went and started soldering things. They're not really hardware hackers. They're not really hardware people. They're not hardware engineers. But they can just kind of solder enough things and drop enough chips in enough places to make something basically work. And that's kind of what we see DevOps, kind of the pressure from DevOps into the orchestration and the IT sysadmin space. So a lot of the stuff, though, is, again, the whole point of this last several slides here is to get people to understand, I guess, my perspective that the confusion or the churn in the software space really comes from the fact that the underlying bedrock of computing that's been there for the last 35, 40 years is changing out. That we're coming to the end of the PC era. And I saw this really, really amazing quote a few weeks back. Someone said that the way we think about concurrency is still slave to abstractions from 1970s. And it's really true. They're talking about threads, and they're talking about, threads, processes, stacks, and sockets, and all these things. These are all concepts invented in the 70s when we literally had like a small microprocessor and maybe a spinning platter, right? So that's really something for people to keep in mind, I think, especially as we're looking at the data world and how we want to use computing to solve data problems, right? We're not trying to just build software. We want to actually deliver business value or deliver insight to our upstream and to the rest of our organization. And so what I would like to ask the question of is, how do we actually go and build on the ideas from the 60s? How do we go even further forward and build in the 1960s instead of the 1970s? Because the 1960s was when they really had a lot of the challenges that we're having now. They had a lot of compute, relatively speaking, and a lot of storage, relatively speaking, and not much bandwidth between them. And they had a lot of people with really interesting questions, well, interesting then, relatively speaking, that couldn't be expressed quite natively in machine code on some of the really janky hardware they had. So we really need to go back to those ideas and think about how people did computing in a way that was bandwidth aware, that was I/O bandwidth, and really focus on those kinds of questions. So when I gave my keynote at PyData New York in 2013, I talked about how we were approaching this from the Python land, what Continuum is trying to do, and all the various technologies that we see coming out of the Python ecosystem. And really, it's around, you can sort of see in some of these, maybe you can't see it because these pictures are very obscure, but essentially, I was talking about the various layers of abstraction that we've built up over the years, and then talking about how we want to move to a point where we're taking a high-level language that is close to the domain expert, close to the data scientist or the scientist, and then we lower their questions down dynamically to whatever hardware or even layer it on top of whatever data architecture they have. And the pictures in the middle are really just kind of deconstructing this idea of what a PC really is. So that video is up on YouTube if you guys want to go and see it and get kind of a deep dive on this deconstruction of a computer, deconstruction of computing and software. But one of the key things we need to do with Python is actually make it better glue. So the reason that we see Python used at so many of those places that I showed kind of one of the first slides is because no matter how many new technologies come along, no matter how many different kinds of questions you have, at some point you're going to be able to take your code, your ideas in Python, your knowledge and expertise you've built up around Python, and hit that particular backend or talk to that particular database. And that's actually been, in the early 90s, in the early 2000s, the conversation on Python was really about Python is a great glue language. You can do, like a web script in it. You can go and do some mail processing script. You can even do science. Like that was conversation around Python as glue. And I think that we're looking at, looking forward to Python being glue 2.0, not so much for like replacing Bash scripts and Perl and things like that, but in the data science side of the world, in the computational science side of the world. I think this legacy as a glue language needs to be extended by actually looking at what the next gen glue needs to be. And it needs to be centered around this idea of connecting data silos as opposed to moving data around. A lot of the technologies that don't work very well right now are centered around the idea of moving data around. And the scientific computing people and the really high-performance computation people have known for a long time that you can't do that. You really have to move your code to data. But it's very important that you move the right code to data. If you're moving very, very low-level, software engineer-generated Java code that really doesn't answer the domain problem, then it's no good to move that code. You really want the data-aware person, the person who is aware of the statistical problems in the data, the questions they want to ask are at this very high domain-oriented level. You want those people to take their ideas and put those in the code. So you really want to connect that end to end. And so that's actually at the heart of one of the DARPA funded. We have 3 DARPA funded projects that we're doing at Continuum. And one of the key ones that's been incubating for a long time now, but is really coming into its own in the recent year. It's a project called Blaze. And what we're really trying to do is deconstruct actually my last slide here, the transcend legacy model of computation. So it's really about trying to transcend or deconstruct that by giving people the ability to express their questions, talk about the schema or the metadata around of their data, and then also describe the computational backend or the computational infrastructure they want to run on, and be able to do all of these things in a first-class way. Many systems nowadays, especially for big data or whatever, they sort of merge 2 of these concerns along one of these edges. And we really want to get to a point where the Python programmer can write some kind of expression, join this, group by that, do this kind of aggregation, filter out with this predicate, and write that expression once, and then be able to run it on a pile of CSVs on disk, or be able to run it on a SQL database of some sort, or go and move it to PySpark on their Hadoop data, or whatever. But they express their problem once, and if their data is stored as a CSV file on disk, or if it's been loaded into Parquet in HDFS, they only have to describe the schema of that data once. And so really the separation of these 3 things, I sort of liken it to splitting the atom. It's a very difficult thing to do well, because you can very quickly find yourself writing a new compiler, very quickly find yourself writing a new database system. None of those things are really that great to do as a bootstrap startup, because those are very expensive things to do well. But what we want to do is just get it so that people can express their ideas. The people who have the most insightful questions, the most domain-oriented questions, can express their ideas in a high-level way. So now back to that taste question. Excuse me. How many people? So taste is actually an anagram of state. I don't know, so whatever. I don't know how many people are around for this. Oh my gosh, poor Steve. That's actually Steve Jobs, looking incredibly arrogant as he talks to the reporter here, the interviewer, about, you know, the only problem with Microsoft is that they just have no taste. And I don't mean that, and the rest of the quote is, I don't mean that in a small way. I mean that in a big way. Okay, so that was Steve Jobs riffing. This is before Microsoft bailed out Apple, actually. But what he was saying by this, though, a lot of people gave him flack about this, right? And so like, oh, Steve Jobs being arrogant. But what he's trying to say here is that the people who made the most money off of the PC revolution, which was not Apple, actually, but all the clone makers, the Dells, the IBMs, and then the Microsofts and the software vendors on top of that, they were rapidly trying to do this land grab, and they're just building out whatever to do whatever to solve people's problems, but they didn't really sit back and contemplate from, you know, a position that only Steve Jobs can, apparently, about, you know, the ineffable qualities that make something, that make sort of something appealing and useful, and then also captures an emotional bond between the user and the computing device. Like Steve really saw computers as, Steve Jobs, I don't know personally, but Steve Jobs saw computers as being consumer devices. They're really devices that people should be using. They're human devices. And so what he meant by this was that they were just building out for the use case. Like Microsoft and the others, they were just building software, just throwing parts and chips around to build something for a use case, but not really considering the connection between the user, the end person themselves, and the object, right? And so this, of course, now in hindsight, we recognize the genius, the particular genius of this in recognizing that there was a consumer digital revolution happening. And so starting with the iPod and then the iPhone and so on and so forth, sort of led to a renaissance in the Apple computer. And I look around and see a lot of glowing apples here, right? Many of you are probably using the command line, using the Unix level interface on your machines, but it's still very nice hardware. And that connection, that taste, is what Steve was really talking about here. And so despite kind of the arrogant posturing of this, there's actually a really interesting kernel of an idea there, which is that you really want to get the technology close to the end user. And so we believe that Python actually has a similar kind of, I wouldn't say aesthetic, but there's a similar kind of connection in that when we look around at the kinds of people who are writing code, or the kinds of people who in any way intersect with code. There's many people who never touch code at all. They, you know, snapshot on their phones, they look up recipes on a browser, but they never actually go and touch a line of code, change a function anywhere. And if we look at the spectrum of people who can touch code, there's obviously a very broad spectrum. But on the one side, we have what I would call analysts. They're people who are using Excel, maybe using advanced Excel with macros and things. Maybe they're writing some VBA, maybe not. Maybe they're just clicking some formula and changing out some value. They're really kind of end-user analysts, but what they do, all right, what they're getting paid for, and oftentimes get paid very well for, is they deliver business insight. They deliver insight to their organization, right? And this is, when I say business here, I really mean generically. You know, if you're a nonprofit research center, if you're a government research lab, it's still the same kind of thing. You have an organization that actually has questions and you need insight. And so people who drive Excel is the most popular data analysis platform in the world. And it's because it's basically at that 80%, you know, Pareto optimal. It just gets you your answers quickly. They may not be the most accurate answers. You may be lying to yourself, but it still gets you an answer that you can then, you know, with plausible deniability, hand off to someone else. Now, on the programmer side, we laugh, but we really should be crying because we all know it's true, right? On the programmer side, we have software developers who, you know, they're told they should learn a new language every year. They get berated, you know, by various tech blogs about how they should be constantly keeping their skills sharp, learning, you know, whether it's Rust or Nimrod or Go or Clojure or whatever it is they're learning this year. There's always some new technology they need to be on the edge of, and there's sort of an egoism kind of thing there around that. But ultimately, the reason is because their skills and their tools are around the production of code. They get paid to make code that works. Now, what it actually does when it's working is sort of not totally their department, right? That's sort of the people who threw the spec over the fence, the program manager who spec'd out the product. But ultimately, the programmer in the trenches, their day-to-day, is punching code into a text editor somewhere and then making that thing work. And in the middle, we have an emerging middle class of folks that write code and don't really want to be writing code, or want to write less code, or want to be more efficient at actually getting to the end result of what the code gives them. And maybe the best way to sort of articulate this is that the programmer sees software as an end unto itself, and the people in the middle see software as a means to an end. The people on the left don't see software at all, right? They don't really intersect with software. People in the middle, though, they see the software, they can see the code, they can edit the code, but really, that's what they really want to be doing is answering the questions and building prettier visualizations and all these various things. And so those people in the middle have, each of these different tiers of folks have their go-to tools. People on the right, that's your traditional Java, C#, C++, JavaScript, web programmer, Ruby on Rails, etc. On the left, these people are using kind of point-and-clicky sort of tools. And in the middle, we have people using SAS and R, MATLAB, Python. And what's interesting, what I sort of have identified, at least in my travels, is that Python actually crosses the spectrum here pretty well. It doesn't get all the way to the far left edge. Your actual end user, person who only knows Excel, they're going to be a little intimidated when they see just all this Python code, even though it's fairly readable. On the right-hand side, your people who are hardcore, embedding assembly in the middle of their C code, they're not going to go to Python, even though they sometimes should. For performance, they really want to be cranking out that machine code. But what we do see is that having Python, having a single language that can cross these technical boundaries and really craftsman boundaries, right? All these different people are crafting something of a sort. And so having one technology platform, one technology ecosystem that all these people can come to is actually a really, really interesting sort of situation. Because now your end user can talk about, your data analyst can actually articulate what they want in maybe a high-level way, maybe not the most efficient, but they can take that and take those ideas and pass them off to someone who can then do the low-level engineering pieces. They can say, well, I'm looking at your routine here. I don't really know the math of why you divided by 2 pi over here. I don't know. But I can tell you that right here you shouldn't be using a for loop. You should call out to this thing, which then parallelizes over the GPU, right? But to have the same code base, to have the same technology suite that all these people can be talking about and talking kind of within is incredibly powerful. And that's why so many people that we talk to, so many small organizations, standardize on 1 or 2 kinds of platforms like this. We oftentimes see R and SAS and MATLAB being used in conjunction with Python. But there's still a large group of people who are using Python, taking those ideas and re-expressing them in Python, so then those ideas can bridge the gap between the end user VP, C-level person, to the low-level ops person who needs to go and deploy the Python on their Linux cluster. So that, and that leads to kind of this next thing, again, about the whole concept of taste and about that connecting to the end user. The reason why intersecting all these 3, having a projection into all 3 of these tiers is really, really important, is because this really lovely Venn diagram that I saw recently, I don't know if people in the back can see it, but the top circle, the blue circle, is subject matter expertise. The left one, lower left, the blue circle, is critical thinking and applied statistics, and the lower right is access to tools. And these are not exactly the terms I would have used, but they're pretty close. And so the idea is that if you have the subject matter expertise and you have critical thinking and applied statistics, that's great if you have both of those, but you have an inability to execute, right? You have this really great idea, you know something about the domain, you know how to do this amazing statistical modeling, and you don't know how to run it on the 10,000 cores that it would need to actually do this at scale. On the bottom connection, if you have the access to the tools and you have the critical thinking and the applied statistics, but you don't actually know the domain, you can do a lot of like cool looking things, but ultimately they're irrelevant. Your conclusions are relevant because a business person who actually knew something about the domain, who knew about power engineering, who knew about human movement and video surveillance or whatever, they could have told you before you even coded a single line of code that the question you're asking was irrelevant, right? And likewise on the right-hand side, if you have the subject matter expertise and you have access to tools, you can go and code a bunch of stuff and click around a bunch of like machine learning things, but you don't actually know the right inferences to draw from that. It can lead you to incorrect conclusions. And so really at the center of all 3 of these, you have a sweet spot. And so what we're seeing, definitely when we talk to data scientists in smaller organizations, they really become the nexus, the place where this stuff comes together, where you have the business people with the questions, the technology people who know how to deploy this at scale, and then they can onboard a lot of deep statisticians and deep mathematical modelers to go and tackle a problem. So it's very, very interesting. And the tool, of course, that we see people using there a lot is Python, because they call us in. There's sort of a correlation there, so it's not, or selection bias, whatever. But definitely people are using Python to use that as a tool in the middle. And really, the point I like to make is that there's this, it's not just about, can you sling code, right? If you want to build a mobile web app, if you want to go and build a website with something or the other, you can go and do that with Python. You can write some Python scripts to orchestrate and configure a cluster of machines. But really, the Python's use in data and computational science is really driving towards what I think of as a kind of this idea of data literacy. And so, when I was growing up in high school, there was these like business leadership classes and everything, and business technology classes in school, and I never took them. But I would see the people going in there, and all they would do is typing. They would learn a little bit of Excel, and they would learn to type. And it's like, that's not business, that's not computing skills. That's keyboarding skills. It's not computing skills. The same thing here, right? Typing and basic, like how to operate, how to close a window, how to double-click a link. These are things that we don't even teach anymore. People just know them. But those things are just, they fade in the background. They're how we do our work. And I think that data exploration and data analysis in the coming sort of water world that we're going to be living in, the tsunami of data coming down on every single vertical, in that world, data exploration and agile data analysis is going to be a survival skill. It's going to be as core a skill as just literacy. And so I call that data literacy. And the thing about literacy, it's interesting, right? I mean, it's the word literate is really around the idea of language, around the idea of being able to express your ideas. And I think that language is, I don't just think, I mean, clearly language is a human instinct. I have like a 1-year-old and she's got language, right? But when we talk to the Python users and we talk to people just casually at meetups and things like that, a lot of people are passionate about Python because they feel like they can actually express themselves. They feel like they're actually agile over their problem domain. And that feeling of agility is actually, it's really ineffable. It's sort of like this taste. It's sort of I would say that agility is the analog of taste, as Steve Jobs talked about, how computers related to consumer digital. Agility and fluidity and expressiveness. These are things that are really hard to capture, but when you've got it, it's really hard to survive without it, right? When I was at the New York City PyData meetup, and it was a host of Bloomberg. They did a wonderful event, and one of their newly hired machine learning experts came up to me, and he was kind of an older gentleman, very, very well-spoken and clearly a sharp guy. But he said to me that, he was looking around, and of course, as a machine learning guy in New York, he can get a job, right? So he was looking around, he was interviewing with Bloomberg, and he basically said to them, okay, here's my stipulation. The salary is great, all that's great, but here's my stipulation. I have to be able to use Python, and on top of that, I have to be able to use Anaconda. So if you make me use some other thing where I have to go and like try to build all this crap, I'm not going to do it. I'm not going to take the job. And so obviously, personally, I found that very validating, but it was just really cool, right? And actually, the other cool anecdote from him was that his daughter was just starting in psychology, something at Cornell, and so they were using R in the department because a lot of the stat stuff is done in R. But additionally, she was also having to learn Python because that's what they were teaching kind of just everyone in the university at the Intro CS. And so that was a very interesting thing for me as well to see. But in general, the idea here is that agility and that expressiveness, like how many people here, if you could not use Python, if you're excited about Python now, if you could not use Python, would you actually start looking for a different job maybe? And if you're sitting next to your boss, you don't have to raise your hand. But I'm just kind of curious, about that, right? Because that's, even if you don't raise your hand, like I want you to think about that, because at this point, if you're doing data science, if you're doing any kind of data analytics, visualization, you can pretty much get a job. There's a lot of demand, right? The job market is really hot. But when you have that kind of opportunity, then it's time to get a little bit maybe pickier or more Steve Jobs-like about the tools we use. And if we can't use the tools that we are familiar with, that we like, then how do we improve that situation, right? And so what that really ties into and segues to what I see as the mission for my company, and I think really for the community as a whole, is that we want to empower the analysts and the data scientists to be able to explore their data and to analyze their problems, but we also want them to be able to share their results. And we really want them to be able to connect with other people who are doing similar work. We want them to learn from each other. We want them to teach each other. And in teaching, of course, you learn as well. And so if we're really on the edge of this era of ubiquitous data, a lot of these traditional software ecosystems and even hardware things are going to get blown apart. And so in the tangled, kind of this like mess that remains after that, I think a lot of new business models are going to emerge. Just like social and mobile emerged as new entire areas of technology very recently, I think that data services, data platforms, data companies, data startups, all those things, I think many people here probably see that. I don't have to do a lot of advocacy for this point, but in other circles I do. But I think that we're going to see a lot of new business models and new ways of making money off technology that doesn't involve just coding or just building chips. And so what we want to do is make sure that people who are doing that are most effectively able to pursue their particular business goals and take a lot of the pain off their plate, a lot of data munging, a lot of the rote deployment and configuration and all this other stuff. Get all that off the plate. And we really think that those foundations, though, obviously many people would love to do that as well in this kind of opportunity, but we think that it would be really, really unfortunate. It would be very limiting if that were done in a closed source way, if that were done in a way that closed off innovation or just put a rent-seeking sort of gate on innovation. And so we really want to build an open foundation for those sorts of things. That's why we, actually, if you look at the NumFocus list here, there's a lot of other languages, right? The R folks are involved, Julia is involved. Many things that we do in the Python land now, especially as it faces modern data science, are polyglot. So the Beaker notebook is a polyglot. The IPython notebook, now Jupyter, is polyglot. Lots of different languages: Scala, Python, R, Julia. Bring whatever you got, right? And the reason is because we care more about that connection and connecting on open foundations. We think that's going to lead to an exponential increase in innovation and an exponential increase in opportunity for everyone. And when I talk about open, though, it's very, very, I've just now started to realize how important it is to articulate what it means to be open in different ways for different people. So for a geek, when you think open source, you think probably, oh, it's licenses, MIT, Apache, BSD or GPL or some other goofy license that some guy did. But it's really about the fact that I can take it, I can fork it, build software, and blah, 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 all this stuff. And that's certainly a part of it. But I think really why people, geeks at least, are interested and excited about open source is because for them, open source tends to strongly correlate to innovation. It strongly correlates to people who just had to solve their own problems so badly, they went and built their own back scratcher, right? And so that's the articulation that the open source, the Open Source Foundation has articulated for a very long time, the idea of people scratching their own itches, as opposed to a vendor selling you a back scratcher, which their market research team told them would target where they think your back is itching, right? Actually, there's a guy who's really itching like me, and he's got the stick he's using. I'm going to take that, fork that stick, actually works, fork that stick, and then use it myself. And so it ties into the utility of it, the value and the innovation, but also the community and the ethos and the culture around that people are going to talk to you about their code. They're not going to go and just shut you down and so on and so forth. And so that really, I think, for geeks is the value of open source. Now, when you talk to what we can, not pejoratively, but what geeks tend to call suits, right? People who actually understand business problems, who have money. Maybe we should have better terms for them. But when you talk to the suits about open source, a lot of times now at this point, people are deploying on Linux. They're using open source tools like Hadoop and Python and R. They understand that open source is not some scary, sketchy people in a basement, like whatever kind of thing. But they really focus on the cost and the value, the ROI. Can I get vendor support? Is there, as actually I was talking to a banker yesterday, and 2 days ago, and had a really great expression. He's like, I need a throat to throttle, right, when things go wrong. He's British and says, I need a throat to throttle. Great term. Yeah, actually, if you're watching this, hi, Brendan. So anyway, so the idea here is that that's what they're focusing on. It's, again, about the cost and the thing. But what I think we should articulate better as geeks, as data scientists, as people doing the work, when we talk to our business side folks, the folks who have the budget, and our CIOs who are making technology decisions, we really should frame the conversation not around the cheapness of open source, but around the innovation. The fact that it's being done by people who are trying to solve the problems. Therefore, it is tied to the edge of innovation. And right now, because we're not in a stagnant 1970s era thing anymore, because things are just constantly coming out, new sorts of stuff are happening all the time, it's incredibly important for people to stay plugged in to that edge of innovation. And so at the end of the day, I was talking to a guy who just had started at a three-letter agency, and it was really interesting. He was just starting to learn Python. Really cool guy. He has a mechanical engineering background, and we started talking about this stuff. Actually, Ben was there, right? I think Ben is here. Yeah, we're having a nice conversation with that guy, and it occurred to me as we were just chatting over beers that really this idea that tooling is a culture. Like the tools that you use and the way you use the tools, languages obviously form cultures, but really tools form cultures. And what we really see as we've been doing all these PyDatas, as people create their own PyData meetups and talk about the things they're doing, we're seeing a lot of people coming out of the woodwork, so to speak, who have been using these tools and who are realizing all of a sudden that they're not the only ones with this particular problem. They're not the only ones who sort of like got the same WTF. Like it's really deeply validating, actually, when you're just one or two people in an organization, a large organization, to be able to go to a place and find out that there's other people like you. And that's like a lot of the value of the PyData conferences and meetups. That's really why we put so much effort into creating the foundation, to get more tools and to get more people supported, more of the developers and a lot of the people who are hacking on these tools are grad students, getting them support, getting them to these places to connect with their users. All of that community building is deeply, structurally, almost existentially critical to the success of these tools. And so my admonition for all of you, my charge to all of you, is to connect with each other and to make the effort to go to a meetup, to go and if there's no one for 3 meetups in a row talking about how a particular tool is being used in a particular way, go and offer to speak. Even just a 15-minute little lightning talk or 5-minute my lightning talks are 15 minutes, but other people, their lightning talks, maybe 5-minute lightning talk just on, hey, I'm using this tool to do this. If you guys are doing this too, anywhere out in the audience, come talk to me afterwards, right? We'll chat. That kind of community building, that kind of connection is what is going to create the substrate for this kind of open innovation. And so that is my personal charge to all of you. Hopefully all of you have sort of can appreciate that many of the tools you're using here, many of the tools that we're presenting here are created by other people who are just like you, who had problems just like you did, and who sat down, banged things out over a weekend. Travis Oliphant, who's not here, he basically spent a year building out NumPy, and we are all really standing on the shoulder of that particular giant. And then, of course, it's a very large ecosystem and community maintained effort at this point. But we're standing on those shoulders because individuals went and did them. They took the effort to build things, to submit bug reports, to submit a pull request and try to fix things. If there's things you like in this world, then in this world, not just in the world generally, but in this world, around the Python world, I'd strongly encourage all of you to get involved in whatever way you can. At the end of the day, PyData is not just like a conference or meetup, and Python isn't just a language. It really, this entire open source movement around open data analytics. At this point, we have a moment to create an open foundation for all this stuff, and it really fundamentally is about changing the culture of how data and analysis is done, and data processing and data analytics is done. And I would invite all of you to kind of be part of that culture movement. So thank you very much. We have a little bit of time for questions, but before we go, I would be remiss if I didn't mention that Continuum is hiring, and we're also selling. As a founder, I have to do this. So anyway, please email me, follow me on Twitter, reach out to me on LinkedIn or whatever. But maybe you have time for like a couple of questions. Thank you.